afternoon all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about pseudo color image processing. So what is a pseudo color image processing? Pseudo color image processing is a technique that maps each of the gray level of a black and white image into a assigned color. This color image, when displayed, can make the identification of certain features easier for the observer. So the mappings are computationally simple and fast. So what are the major areas? Full color processing, pseudo color processing. So what is a full color processing? The images are acquired with a full color sensor, that is a color TV camera or color scanner. Pseudo color processing is images that are generated by assigning a shade of color to a monochrome intensities or range of intensities. So pseudo color processing is a technique that maps of each of the gray levels. Gray levels means black and white. Levels of black and white image into a assigned color, and the color image when displayed can make the identification of certain features easier for the observer. The mappings are computationally simple and fast. So what are the major areas of the pseudo color? Means full color processing, pseudo color processing. So what is the full color processing and what are the pseudo color processing? We'll discuss. The images are acquired with a full color sensor, that is a color TV camera or color scanner, and pseudo color processing. The pseudo color images are generated by assigning a shade of color to a monochrome intensity or range of intensities. And pseudo color image processing approaches for assigning color to monochrome images based on properties of gray level content. And monochrome images, the term monochrome is usually taken to mean the same as black and white or more likely grayscales, but may also be used to refer the other combinations of containing only tones of a single color, such as green and white or green and red. So what are the approaches? Intensity slicing and color coding, gray level to color transformation, filtering approach. These are the three color approaches. First one is a pseudo color image. It is approaching for assigning color to monochrome image based on properties of gray level content. Another is a monochrome image. The term monochrome is usually taken to mean the same as black and white or more likely grayscale, but may also be used to refer to other combinations containing only tones of a single color, such as green and white or red and green. So what are the approaches for the monochrome images? Intensity slicing. Intensity slicing means we are changing the intensity levels from black and white to color or color to black and white, and gray level to color transformation, filtering approaches. These are the three approaches. And what are the main categories of image processing? Pseudo color image processing, that is a false color. Full color image processing, that is a true color. So true color versus false color, that means full color image versus pseudo color image. So true color means full color or the images with natural color retention. A red apple appears as a red. Suppose I am taking one example, red apple, it appears as a red. A blue ocean appears as a blue, etc. It's difficult to achieve absolute true color in an image, but being approximately close to the human perception is substantial. True colors. So true colors can't change to other color. Why? Because these are the human visible colors. Human visible colors, that is a ocean and a red apple, blue ocean. These are the difficult to change the original colors. Means why? Because these are the human visible colors. And false color images. False color means it is a not real. Why? Because we are combination of two colors, combination of original colors. That is the false color. Okay. The satisfactory, the sacrificing, the natural color rendition in order to facilitate the detection of some objects. They are mainly used for satellite and space images. Originality is missing in the original image. So in the original image, what are the color combinations are there? Those originals are missed. So that is a false color image. So there are two types of colors are there, true color and false color. So true colors means can't change the original color. False color means changing in original. So changing in original color, that is a false color. Means suppose NASA pictures, satellite pictures. These are what will happen. The original of the original pictures are missing. So pseudo color images are originally grayscale, which are assigned colors based on the intensity values. Typical usage of these images is for the monography, where the only available is infrared radiation instead of lights. Another example is a elevation map. Here taking it is a one example of NASA picture, but what is happening? It is not a original picture, but due to some noises or whatever maybe the originality of the image is missed. That is a false color. So the originality is missing. It is looking like not a visible, but human. It is not in human visible system. It is not in human visible system. That is a false color. But we have to change to human visible system. So change to human visible system. That is a true color. So false color is changing to the true color. So the originality of the grayscale, which are assigned colors based on the intensity values. The typical usage of these images are for the monography, where the only available in infrared radiation instead of lights is another example of elevation of map. So here I am taking degrees or Faraday. So what are the intensity levels? These are changing from 20 to 35 or 70 to 94.7. So what are the color combinations are there? We have to find out. That is a pseudo color image. That is a false color. And what is the intensity slicing? This is a simple case of pseudo color image processing. It is also called density slicing or color coding. Density slicing or color coding means what is the original color, how we have to change that one. So that is a intensity slicing. Intensity means changing the intensity values. So intensity slicing is a simple case of pseudo color image. It is also called density slicing or color coding. So imagine a grayscale image as a 3D function with the intensity being the third dimension, but placing a plane parallel to the horizontal plane for the pixel position coordinate would slice the image into two parts. After that, we can assign different colors to the different levels. It is one example of geometric interpretation of the intensity slicing technique. So I am taking x-axis, y-axis and z-axis. So here x-axis is a black and white combination. Here I am taking, so it is one intensity slicing plane. It is an intensity level. So intensity axis, that is a f of x comma y, combination of x and y, black and white. That is a intensity color slicing. We are not constrained to use only one plane. Multiple slices result in more flexible representations of the grayscale images. In this grayscale is plotted into intervals and each one is assigned to a different colors. Here I am taking image A and image B is there. What is the image A means? Result of density slicing into 8 colors. So result of density slicing into the 8 colors. So here input and it is a output. So what is happening means intensity slicing means color combination. It is a color combination. So intensity to the color transformation. We can generalize the above technique by performing 3 independent transformations on the intensity of the images. The resulting in 3 images which are the red, green, blue. So these are the components images used to produce the color image. So red, it is the image used to produce a color image. It is not the combination of color image. But what is happening here? Intensity of the color transformation. We can generalize the above technique by performing 3 independent transformations on the intensity of the image, resulting in 3 images which are the red, green, blue component images used to produce a color image. And f of x comma y equal to red transformation, green transformation, blue current transformation. That is the R plus G plus B. But what is happening means, what is the output of red means FR of x comma y, green is FG of x comma y, blue is FB of x comma y. So the functional block diagram for pseudo color image processing is a f of x comma y equal to R plus G plus B is equal to FR of x comma y plus FG of x comma y plus FB of x comma y. So it is a pseudo color image processing combination. So the flexibility can be even more enhanced by using more than one monochrome image. For example, the 3 components of an image are GB and the thermal image F of F1 of x comma y, F2 of x comma y, Fk of x comma y. So on means k number of inputs. So if I am taking F1 of x comma y, that is a transformation of T1. F2 means transformation of T2. K means transformation of Tk, means k number of things are there. So what is the pseudo color output? G1 of x comma y, G2 of x comma y, so on Gk of x comma y. So what is the additional processing? Additional processing means what are the additionally we need for the external. So HR of x comma y, Hg or Hb. So F1 plus F2, F2 plus F3 equal to G1 plus G2 plus G3 is equal to HR plus Hg plus Hb. So red, green, blue. These are the flexibility of the enhanced color of the monochrome image of the 3 components of RGB in the thermal image. So this diagram is a multispectral image processing, which is a transformation of original image into the red, green, blue combination. So these are the references. So what are the pseudo color processing technique? It is the gray level of the image with black and white into the ascending color. This colors image when displayed can make in identification of certain features of easier than observer. So 2 major areas are there, that is a full color image processing and pseudo color image processing. Full color means the images are acquired with a full color, that is a color TV camera or color scanner. Pseudo color image processing means pseudo color images are generated by assigning a shade of color to a monochrome intensity or range of intensities. And pseudo color images are approaching to the assigning a color to the monochrome. And so what are the monochrome means? It is a likely a grayscale combination, that is a green and white or green and red combination. So what are the approaches for monochrome images are means intensity slicing or color coding, gray level to the color transformation, and filtering to the filtering approach. And what are the two main categories of image processing is pseudo color, that is a false color, full color means a true color. So what are the true colors and what are the false colors? So here we are discussing true color versus false color. True color is the natural color, that is a red, green, blue. So we are not adding any more or anything. We can't change the originality of the original image. And false color means due to the noise, the originality or original input images are changed due to the noises. So the colors, original colors are missing. So those are the false color. So false colors are converting to the true colors. How? What are the methods I am using? Means here pseudo color image is a originally grayscale image which assigned colors based on the intensity values. Typically usage of these images for thermography, where the only variable of infrared radiation instead of lights. Another example is an elevation map. So what are the intensity slicings? It is also called density slicing or color coding. So the image in a grayscale is a 3D function, and what would be the slice? The pixel position of coordinates with slice the image are the two parts. After that we can assign different colors to a different levels. That is a slicing. It is a block diagram or intensity slicing technique, means slicing plane and a combination of white and black with x and y axis, and it is the input and output images, the result of density slicing into the 8 colors. So input is a normal noisy colors and the originality is missing, but I am getting the originality of the input image with the pseudo color combination. That is a false color is converting to the true color. Okay, so I'm adding the noises, removing the noises, and we are converting to the originality of the color. That is a pseudo color image processing. So the intensity to the color transformation. So intensity levels are very, very important. So when the good image with the 255 intensity values is a good color image, and the intensity also good. Here the example of a pseudo color image processing, red, green, blue. So what are the inputs means f of x, y. What are the output means fr of x, y plus fg of x, y plus fb of x, y. So what are the combinations means red transformation, green transformation, and blue transformation. So the flexibility can be even more enhanced by using more than one monochrome image. For example, the 3 components of a RGB and a thermal image. So f of x, y, f2 of x, y, and fk of x, y. So the transformation of T1, transformation of T2, and the transformation of Tk, k number of transformations. It is called multi-spectral image processing. So what are the outputs means? Input is a f1 plus f2 plus f3, and the color combinations are g1 plus g2 plus g3. Finally, what is the output we are getting? Which color we are getting means gr plus hr plus hg plus hb. These are the output color combinations. It is a multi-spectral image processing. It is about pseudo color image processing. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.